Hi, I'm Chris from airwindows, and just as I thought I was done with all the other stuff, I came up with another one, so I'm going to give it to you. Here, it shouldn't take very long. This is a little demonstration of my usual dithery process. This is flat dither, and let's see some TPDF. So as you can see, TPDF is easy to understand. It's just a normal dither process, which seems to have... Okay, all the more amusing. Well, when it's playing TPDF, that must be hitting... Fascinating behavior we have here. Okay, so we have the magical fading out TPDF dither. So what I can do is keep it playing. The DAWs, man, do the strangest things. You turn your back on them for half a second and it's like, what is it doing? So we have a DAW that's fading out TPDF for some reason. Even though, let's see now, if I turn this off, we'll have bit shift gain, but it'll be full loudness. And it's still fading it out. Very weird. However, we also have TapeDither, which is doing the same thing again. And I've got no plugins in the output. Okay, today Logic wants to fade out my audio when I'm not playing it. So one thing I can do about that is keep it playing. So this is TPDF dither, and by example here is flat. Sounds very similar. TPDF is a little bit louder. Now I came up with TapeDither because TapeDither is something that, well, basically Paul Findle showed me. He claims that, oh, it's just something everybody does, and he is not to be particularly thanked for it. I guess I'll just thank him for just being awesome. I don't know. But TapeDither sounds like this because it is a high pass. It uses the two random sources, but it uses them by having one, saving it, and then flipping it over for the next sample, inverting it, causing us to have a low frequency reduction algorithm. That's what happens there. I was experimenting with these things, and I wanted to create something that I was going to call node dither, because if you put in, well, here, I'll show you. Fox Uncle Span. Always love Fox Uncle Span. So we're going to be editing it to get more of a noise floor. Again, I think this low frequency bump is simply a tiny amount of offset around the lowest significant bit. If we go with flat, it's much the same. Okay, well, that was interesting. These DAWs, man, sometimes. And if we go to the TapeDither, here, I can even edit the slope here. TPDF is flat dither. So if we go to TapeDither, you can see that that has a slope in it. Well, in experimenting with the node dither, I was trying to do a thing where the cancellation of the effect, here we'll slope it a little bit just to have it look the way it normally does. After all, it's white noise, not pink noise. Here's what I'm talking about before I go on too long. Boop. And interestingly, our channel is happily continuing to show this even though I'm not hearing it on the audio. Go figure. This is what you'd call a node. It differs from this. Give us back, thank you. Because this is a high frequency cancellation that lowers some of these lows out of here. It's making it go quite a bit down. Because it's one sample immediately followed by the next sample, there are no cancellation effects. Cancellation effects are like what you get when you have a surface near your voice and the sound of your voice goes directly to the microphone, but also bouncing off of the surface and onto the microphone. You get two copies of the audio waveform and they combine destructively. So what we get here is with a single sample, come on, wiki. It's a brighter hiss, but one thing about this that I noticed, it's good at clearing up these low frequencies. Like you can see with the plugin sitting here in the way of the window. When we kick in TPDF, it's noticeably higher than when we go for the TapeDither. We're getting a cut in how much the low frequency noise is coming through. This is the purpose of using a high pass. It's making it seem like it's a little bit quieter. It's redistributing the energy. Now my concern there is simply that it's really bright. This is very bright. And I don't tend to like digital sounds that accentuate these super duper high frequencies. I tend to think it's kind of fatiguing. I wanted to make a thing where, see this little notch here? You could swoop a notch right down to around 1.5K, which is a place where the human ear is very sensitive. And I experimented with that. And in fact, it kind of worked. I could get a notch to go down there. The trouble was I had all this comb filtering stuff that was also messing up the sound, and I didn't like it. It didn't sound very good. And I don't think I have no dither on this one, but so what I ended up settling on is 4 samples of delay. And 4 samples of delay gives you this. 2 samples also gives you this, but without the notch here. And then 8 samples gives you another notch around here or whatever, but it starts to become weird and overly colored. Now the difference between these, I just feel that like if you're listening through the noise floor, and you got music going on here, this is straight TPDF dither. You can really hear the noise of it a lot. It's making this loud hiss, and it sounds to me like a digital hiss. You know, I don't like the sound of this that much. Natural hisses aren't digital hisses. Natural hisses are things like brown noise. They are the behavior of wind through the trees or whatever, and distance causes the high frequencies to go away on that much more. What you get is noise that doesn't really blast you so much in the highs. It's a lot softer. Now, if you go to TapeDither, well, here's the thing. We've cleaned that up a lot. It's easy to hear how the low frequencies are not being dominated by this dither noise anymore, but we've only made the high frequency issue worse because it's just all the highs now. So with the delay of the inverted sample, the inverted random noise, boom, all of a sudden we've got something that resembles the noise profile we get off of analog tape. I chose this amount of delay on the sample for exactly that reason. I was experimenting around and trying to find what just tended to resemble tape noise better. And to me, this is a pretty restful noise. You can plainly see how there is this dip right around 10K. And that's not so unusual because I was researching how tape machines do their biasing and the tape noise, the pre-equalization, the post-equalization. There's a lot of different ways that tape machines minimize noise, but this is pretty fundamental to them, that there is a pre-emphasis and then there's a roll-off, and it'll often kick in around here. Now we do have, as you can see plainly here, this area where, it drops off really good going up to about 10K, and then it increases a whole bunch going up to, this is going to be close to 20K. In fact, I can find out exactly. 17K. It peaks out at 17K. So that suggests that people who have really good, really young ears, might hear the sort of notiness of this a little bit more. But when you consider what regular dither, this is our 24-bit, back to our quiet, mellow-sounding tape dither, then the high-pass dither, it's very good at quieting things down, but this is the same process tape dither is doing. You look down around here, you look down around the low frequencies, and that's pretty close to 96 dB down. You go over to the tape dither, same deal. Same deal. What this has done, with the choice of putting an additional delay into the original use of the noise and then using again in inverse, that delay has done nothing but shaped the behavior of the high frequencies. And if you keep adding delay, if you keep slowing it down, these nodes keep sort of swooping down here, but then it becomes this extremely obvious, kind of obnoxious flangy noise. Now, I think there are probably some people who will hear this dip up to here, and then it's doing another dip as it goes out to Nyquist, being the point where here I can even show you. I think I'm not really showing this perfectly. There we go. Here's where the frequencies stop. Here is how the high pass works, is it just keeps getting louder until the frequencies are done. Here's how TPDF works. Same deal, but without a boost. And you got more noise down in the low frequencies. And then here is how TapeDither works. Roughly the same amount of noise. I mean, technically it's exactly the same amount of noise because it's the same amount of noise as TapeDither. It's doing the two TPDF sources. So it is a perfectly correct TPDF dither. You can hear that I'll set it to just hint delicately at the sound. You can hear from this that it is a functional TPDF dither that's using the two noise sources. There is no interaction with the noise levels at all. But because of these delays, it has this roll-off here. And then it goes up, and then there's another roll-off here. And it goes out, it goes into the Nyquist frequency in a way that's very similar to if you were capturing sound recorded off of a real tape deck into a digital system. Because we often see this when we are recording stuff and it may be noisy or whatever, often it'll start rolling off around the Nyquist frequency. Stuff doesn't really hang on to its full volume when it's coming from an analog source. So this is basically a dither that is made to react as if the dither is part of a tape machine analog source out in the world that you're sampling. And again, we compare it with, say, TPDF, truncation. No, that's horrible. Or TapeDither, which is high pass. I named it after him because I got the idea from him, okay? And TapeDither, again, just as efficient as TapeDither. It's still generating only one random source per sample. So it's twice as CPU efficient random-wise as generic TPDF is. But it does the high pass, so it's a lot quieter down around the low frequencies. And it's coloring the tone of the high frequency hiss that you get, making it sound like a tape machine. So what we get is perfectly normal music, but this is at 8-bit. And then if we were to shut these off, now at the 24-bit level, you can't really hear this, but all the same, dithering is something that we do when we reduce word lengths. So when I turn this on or off in the actual audio, and this is actually showing my point here. A normal piece of music recorded will often roll off around here. Like this is a synthetic piece of music, and it's still rolling off because it's using samples for those high frequency noises. When you kick in TapeDither, say with cutting the gain like that, at 24-bit we don't really hear it. But all the same, dither is the correct way to handle reducing word lengths. And that's why we've been going on about it. That's why we're fussing about it so much. What's happening down in the lowest details of your audio is essentially this. I have to shut this off first. So what we want to do is make sure that across the entire digital audio we're not sort of cumulatively adding bad noises like, say, we can take away the bit shift gains, we can put this down to the quietest parts and you would struggle and strain to hear this, but this would still be there. Now it might sound kind of cool, but do you really want this? To be in your music, especially if it's not intended to be like noise industrial music. There's no reason to have any of this sound at any level. It only adds up, it only builds up. Each time you go through this process, you get a little more of this, or you could have a little more of this. I hope you like airwindows TapeDither, and I will be continuing to do more dithers until they are done. They will finish off with the amazing naturalize, which sounds kind of like this. It's a bit of a strange bird. Of course, what we got here is a noise quality, but it's a noise quality that's easily listened through. Like you start listening to the audio of it, and then you stop hearing the noise as it goes. But that's enough of that for now. So enjoy one extra dither. I wasn't planning to do this one, but I had the idea, so I thought I would give it a shot. I don't think anybody has ever done specifically this. Boop, boop, and boop. I don't think anybody has ever done this dither before. I mean, we've got this. This was in some of the Sony Oxfords. This has great things about it, but it also has that tendency of extreme brightness because it's a high pass. But I don't know if anybody has ever done this one. Because the thing about it is, it's a roll-off, but since it is delay causing a comb filtery type effect, it's cancellation nodes. It's this funny way of behaving, and people don't automatically turn to this kind of stuff and go, oh, I'll have some of that. That'll be great. But listen to it. As far as a tape machine emulation, this is pretty great. And it's also TapeDither that you can put on all of your audio every time you truncate down to 24-bit or adjust with the bit shift gain for other bit depths. I hope you like it.